Good morning one and all, respected teacher and my dear friends. So in this video, I'm going to explain the working principle of a counter circuit and how to make a simple counter circuit with their components and their cost. So let's get started. These are the topics which we will discuss in this presentation. As you all know, a counter circuit is a circuit which counts and shows the value on the digital display. Digital counters are needed everywhere in this digital world, and 7-segment display is one of the best components to display it. The circuit which we will discuss in this presentation will count from 0 to 9. These are the names of the components and their cost. So the estimated cost for this project is 239 rupees. In this circuit, we have used a transistor as a switch and used LDR to on and off the transistor with the help of a potentiometer and a laser light. The LDR is connected to the base of the transistor, so when the light is disconnected on the LDR, the collector and emitter short circuits, and then the positive voltage gets to the clock of the IC4026. So before I explain you the circuit in detail, I will like to discuss the 4026 IC and 7-segment common cathode display. The 4026 IC is a 4000 series IC. It is a CMOS 7-segment counter IC and can be operated at very low power. It is a decade counter which counts in decimal digits. So as you can see, this is the pin configuration of the IC4026. The pin number 1 is the clock pin. The clock pin will increment the counter with each positive clock pulse from low to high. The pin number 2 is the clock inhibit. When it is low, the clock pulse increments the 7 segment, and when it is high, it will freeze the counter. The pin number 3 is the display enable. The chip will be on when this pin is high and off when it is low. The pin number 4 is the display enable out. It is used for chaining 4026 IC. The pin number 5 is the carry out. It completes one cycle every 10 clock input cycles and is used to clock the succeeding decade directly in a multi-decade counting chain. The pin number 6 is F, which is connected to the F of the 7 segment. Pin number 7 is G. Pin number 8 is the VSS, which is the ground pin, and pin number 9 is the D. Pin number 10 is the A. Pin number 11 is the E, and pin number 12 is the B. Pin number 13 is the C. Pin number 14 is the ungated C segment. It is an output for the 7 segments C segment input, which is not affected by the DE input. The output is high unless the count is 2 when it goes low. Pin number 15, it is the reset pin. It is active high and it resets the counter to 0 when it is high. The pin number 16 is the VDD, which is the power supply pin. The 7 segment display consists of 8 LEDs whose cathode is common. There are total 10 pins in which 8 of the pins are used. So now I would like to explain on how the circuit works. So in this circuit we have used an LDR and a laser light to on and off the transistor. The transistor is used to hide the clock pin of the IC4026, which increments the count on the 7 segment display by 1. The reset pin, which is pin number 15, is used to reset the count. The pin number 5, which is carry over, will stay high by default, but when the count reaches to 9, it will give a small pulse and the count will continue from 0. So to make this circuit, we need to connect the LDR to the base of the transistor, emitter to ground, and collector to 1 kilo ohm resistance. Then we need to connect the collector to clock pin of the IC4026. Then we need to ground the clock inhibit. display enable in, display enable out, and VSS with the LDR. Then we need to connect the 10 kilo ohm port to the pin number 3 and pin number 8 of the 7 segment display. We need to connect pin number 1 of the 7 segment display to E of the IC, pin number 2 to D, pin number 4 to C, pin number 5 to DP, pin number 6 to B, pin number 7 to A, pin number 9 to F, and pin number 10 to G of the IC. Then we need to give the power supply to the resistance. The applications of counter circuit is it is used to count people or objects. It is also used in digital watches, digital timers, digital stopwatches, and also in calculators. The advantages of counter circuit is that it can be used for longer duration with minimum maintenance. It can be easily installed and it is also available in semi-automatic to automatic modes. And its operation is also quite faster. The disadvantages of counter circuit is that there are chances of operational error and it is medium to heavy in weight. I would like to conclude this presentation by saying that digital counters are needed everywhere in this digital world, and it's quite easy to make one simple counter circuit as I explained their working principle and their components required to make one in this video. Thank you for watching this video, and I hope that my video help you in some manner.